In this lesson, we're going to look at a more complicated trig identity. Now we have to prove that sin x plus y times the sine of x minus y is equal to sine squared x minus sine squared y. And we'll have to keep in mind this idea here. These won't be given in the formula sheet, but we need to know these that sine squared alpha plus cos squared alpha equals 1 and tan alpha equals sine alpha over cos alpha. So as before, start with the left hand side and see if we can do things to this to make it equal the right hand side. So the first thing I can do, I can see that I can expand this and this. So this is going to go to the sine of x cos y plus cos x sine y, just this bit here. So write that out in brackets. And you're going to multiply all of that by the sine x cos y take away cos x sine y, just using your formula sheet. Now the next part, we have to basically multiply these double brackets out. So you're really multiplying this by this first of all, and that's going to give sine squared x plus cos squared y. Sine x times sine x is a square in it, and cos y times cos y is a square in it. So the next thing you want to do is you want to multiply these two together. And that is going to give cos x sine y and sine x cos y, and you can write that like this. So that's that times that. Then you want to multiply this by this. Just like multiplying out normally, double brackets, and that's going to give you that. You can see I've just used the purple and the green in the takeaway. And then you want to multiply the green and the blue together. So this here by this here. And if you notice, it's going to be cos x squared or cos squared x and sine squared y. So that's quite a tricky bit there. But what we should see is we've got cos x sine y and sine x cos y. Take away cos x sine y, sine x cos y. So these things are basically going to cancel each other out, which leaves us with this. Now, at this point, what I would do is have a wee look back to see what we're trying to end up with. Now, we really just want sine squared x take away sine squared y. So we want the black bits here. We don't really want the red bits. So what I thought was, well, I don't really want a cos squared y there. I need something to substitute in its place. So I'm going to use this, but I'm going to rearrange it so that cos squared y is equal to 1 minus sine squared. And cos squared x is equal to 1 minus sine squared x, thus getting rid of the cos and the cos here. So if you substitute that in, then that looks like this. Now because I've substituted this in for this part here, I've ended up with brackets. So I need to have everything in square brackets here as well, because I'm subtracting two things from each other, as well as having the multiplication brackets. So the multiplication brackets are here, but I need the square brackets to separate the two terms that I'm subtracting. And that really helps when you're multiplying through by -1. So let's multiply the bracket out first inside the square brackets. So let's do this one. So I've got sine squared x times 1, and then I've got sine squared x times sine squared y. So that's going to come to this. Take away. And then let's multiply this curved bracket by the sine squared y. So that just works the same way, although it's at the end, you're going to do that times that, and that times that. So it's going to be sine squared y take away sine squared x cos sine squared y, sorry. Now, it's really important here that you make a note of the fact that there's a negative 1 there, here. That's really multiplying this bracket here, this second bracket, by negative 1. And some people miss that. So when I do that, the first is going to stay the same. There's nothing going to happen here. But that's going to be take away sine squared y. But it's going to be a plus sine squared x sine squared y. So again, what you should notice at this point is the fact you've got a takeaway here, sine squared x sine squared y, and a plus sine squared x sine squared y. So they're going to cancel each other out, and you're going to end up with this, which is equal to the right hand side.